Good morning, good afternoon, and good evening, dear colleagues and learners. Today I want to talk to you about AC mitigation systems. There will be times when you will be asked to evaluate or commission an AC mitigation system. These mitigation systems were extensively and previously studied to ascertain and determine their locations through specialized software simulations, where the areas that may experience potential electrical discharges from the power transmission lines are identified in detail. Alternating current mitigation systems are installed because gas or oil pipelines receive alternating current voltages either by inductive, conductive, or coupling methods, where these voltages can reach dangerous thresholds for the safety of personnel, operators, custodians, or pipeline owners. But it also represents a risk for the mechanical integrity of the pipelines because it can cause accelerated corrosion. So most of the time, these control points where the mitigation systems are installed, always through sound engineering practices, should have this test point, test station, test lip, control points, measurement points installed. Define them as you wish, but in themselves they consist of some measurement posts with some cables welded to the pipe, another cable welded to the coupons, and another that has a reference half cell. I am going to show you all the measurements that commissioning should consider. I am going to show you a list in the style of Pedro Morales, or as my teachers or my tutors have taught me in this career. And, well, the idea is to try to share. And, as always, gentlemen, take the good, discard the bad. Sometimes there are things that are of no use to you. You simply do not pay attention to them. A mitigation system typically consists of AC systems with a linear anode in parallel to the pipeline, which are usually zinc linear anodes installed at about the same depth as the pipe. Before we dive deep, don't forget to subscribe to my channel and turn on notifications. Stay updated with my updates.
As I was saying, this is a typical mitigation system where we have the coupling system that consists of a solid state SSD. We have the test station, or whatever you want to call it, where we can see that there are different terminals, and my goal is to teach you how to take all the measurements at these points where we have corrosion coupons.
We need to be very clear on how to connect the multimeter to the different terminals and how to measure AC voltages and DC voltages. But we also need to be clear on how to measure currents. Likewise, we can see that we have a manual interruption switch where we can make on-off interruptions, meaning we can measure free potentials and resistance. Therefore, we have the ways and means to do this here without needing to interrupt the rectifiers themselves.
You already know my style. You know my style. We're going to do it the Pedro Morales way in practice, teaching you step by step. and of course, guiding you through a procedure, a protocol that you can adopt for your future inspections. Many of you are going to ask me to send you the format, to send you the classified document in Word or Excel. I have no problem doing that, but I want to clarify that I only do it for people who are subscribed to my channel, who like my content, and I ignore those who don't. Sometimes they get upset and say, Pedro ignores me, but it's not a lack of respect. The lack of respect is theirs. I have no problem sharing my knowledge. I'm one of those who believe that everyone should have access to information. The knowledge should be everywhere, in all states, conducting all the inspections. No, which goes out to me. Without further ado, folks, I continue. This is the mitigation system as such, where we can see the decoupler, which is a solid-state SSD that also has a manual interruption switch. In my personal opinion, it's great, because this indeed gives us safety to operate and take measurements. What it allows me to do is, right now, it's active in the on position, but by flipping it, I can temporarily or momentarily deactivate it. So it has two measurement points at each end, allowing me to take measurements here without having to reach down there and put my safety at risk. But you can see that it's visible. There are two wires that have a red tape. Those are the ones connected to the zinc linear side. And on the other side, you can see it says negative on the pipe. So, tremendous risk. This is what the mitigation system is made up of. You're going to take measurements. Okay, folks. Continuing with the explanation of how to commission a mitigation system. We need to be clear about the measurements we're going to take. We're going to measure the voltage of C. We'll place the negative of the multimeter here on the yellow terminal and the other one on the blue terminal, which is the test coupon for measuring 600 volts. But for measuring AC voltage, we're also going to use this same coupon. We won't use this coupon, only the orange. One is used to measure current. But when we go to measure currents, we'll connect it to the structure. That is, the structure number 102. And we'll set the multimeter to milliamperes and interrupt the switch. We're going to do the same to measure the alternating current. One goes to the pipe and the other goes to the orange terminal, where the red wire and the black wire of a multimeter go. I made a video for you on how to handle current, and I would appreciate it if you watched it, because it's important for you to understand how to connect this, what you need to calculate from the campus, how to select it. This is like commenting on the reference cell or the positive one. And so I've mentioned this goes directly to a more positive structure. If it's not the most positive, it's the closest to make the type. There we have a potential of 1.400 kilograms.
manufactured 5009. Another thing. No, we're not going to come running the after from that side, right? At least 30 times. And it will go to the ground. After a period of 30 days has passed, we will be able to create a detailed comic strip. This comic will serve the purpose of measuring the electrical currents that are essential for our testing process. It will clearly indicate the direction in which the negative current flows, as well as the path taken by the positive current. By doing so, we ensure that the testing is accurate and that the results are reliable. This comic will be an invaluable tool in our testing arsenal, providing clear and precise information about the current flow. 15 volts. Measure AC milliamperes. Connect invader. Milliamperes. Alarm positive. A voltage of 2 and approximately 15 volts gives me an instruction on how to do it in a detailed and systematic manner. Likewise, measure 80 milliamperes. It says I need to connect in the future, as well as with oil. However, I also need to make an invader here. I should place the milliamperes. Although currently incorrect, the alarm going off incorrectly. But here it tells me that I need indeed set into positive mode. It's simply indifferent to do it than to do it. The direction of the current changes approximately every 60 seconds. 60 times every single second. For the important measurement. With milliamperes, I have 0 and 14. I make my interruption. And that's my reading of milliamperes. Obviously, that's what I feel like. We have a risk of corruption due to the voltage current from the phone. In this particular case, we have 0.9 milliamperes, which means there is no current flow at this specific point. However, you need to perform the conversion if you want to. Proceed with the conversion process accurately. The same manufacturer, who provides us with detailed specifications, tells us what the voltage amplifiers are in a parrot, which is a term used to describe a specific measurement unit or condition. Okay, then it further instructs us on how to measure the sea, so the earth, which is a critical step in ensuring accurate readings and results. This measurement process involves using precise instruments and following the manufacturer's guidelines closely to avoid any errors. But it tells me for current. Not good. Then on my grandfather's side, as you might know,
notice it dropped to 470. I can provide the list and the manufacturer informs me later. To measure, we have a coupon of 500, 508 volts or 508 millivolts. It explains how to measure current. The negative goes on the structure, positive on the chemical. If the value is positive, current enters behind the coupon towards the pipe, which is desired. This means methodical protection surrounds the coupon and current enters the pipe, which is desired. This is what the manufacturer tells us about taking measurements and connections. Commissioning involves more measurements. Here's a diagram of records to consider. After explaining current and voltage measurements and protocol, these are all measurements for commissioning. Pause the video and zoom in to see the protocol. Let me remove this, take out the multimeter, place the tablet horizontally for clarity, and adjust. Let's focus on the measurement step by step. Record the site, location, coordinates, date. All data is important. Record SSD readings in cold SSD readings. Measure AC current as found, connected, under normal conditions. Measure the 600 found with SSD connected. Measure AC potential on SSD and its values. Measure AC potential with SSD disconnected on pipe side. Check my other videos for evaluating SSD, measuring them, and verifying coupling or decoupling. Because if the value comes out positive, it means that the current is entering behind the coupon and going towards the pipe. And that's what I want to see. This means that the methodical protection is in the environment surrounding the coupon, and that current is entering the pipe, and that's what we want. Well, basically, this is what the manufacturer tells us about how to take measurements on the coupons and how we should connect them. However, commissioning involves more measurements. I want to show you a diagram I have of the records we need to consider for that. We'll be back in a moment. Okay, folks. After explaining how to take current and voltage measurements on the coupons and what the protocol is and how the manufacturer indicates these should be done, these are all the measurements that should be included in the commissioning. I'm leaving it this way so you can pause the video and zoom in to see this protocol. Anyway, let me do something. Let me remove this from here. Let me take out the multimeter. Let me place the tablet horizontally so it can be seen more clearly. Let me adjust this. Okay, right now, let's not focus on this. Let's focus on the measurements we need to consider so we can go step by step. We need to place the site where we are doing the commissioning, the location, the coordinates, the dates. All that data is important. We have to record the readings of the SSD in the cold SSD reading. My God, we need to measure the AC current as it was found, connected, everything normal, under normal operating conditions. Then we will measure the 600 found, but with the SSD connected. After that, we will measure the AC potential on the SSD and what those potentials are. We will measure the AC potential with the SSD disconnected, but on the pipe side. And if you ask me, Pedro, how is that? Check out my other videos where I have explained how to evaluate the SSDs, how to measure them, and how we verify that they are coupling or decoupling. I invite you to watch my other videos. After that, we will measure the AC potential with the SSD disconnected, but on the grounding side or the anode side. Check out my other videos where I've explained how to evaluate the SSDs, how to measure them, and how we verify that they are coupling or decoupling. I invite you to watch my other videos. Then we will measure the AC potential with the SSD disconnected but on the grounding side or the anode side. The same thing is going to happen with it. We're going to measure the 600 voltage on the SSD but on the negative side. Then we will measure the 600 voltage, the potential, on the SSD but on the positive side, while it's disconnected. Next, we're going to measure the potentials on this roof, here, and we're going to measure on the 100 square centimeter coupon. We're going to measure the on potential, the AC potential, in on, the AC potential, in off, the 600 potential, in on, and the 600 potential, in off. On the AC coupon, we're also going to do the same thing. We're going to measure the on potential in AC, the off potential in AC. Then we're going to measure the on potential in DC and the off potential in DC. Next, we need to measure the AC voltage of the pipe and the AC on the coupon with the SSD connected. We're going to do that connected, measuring the AC voltage between the pipe and the coupon, and then the AC voltage between the pipe and the coupon. After that, we're going to measure the AC voltage between the pipe and the AC coupon with the SSD disconnected, meaning we'll do it first connected and then disconnected. Next, we will measure the 600 O voltage between the pipe and the coupon with the SSD connected. These are the measurements we need. Watch closely and follow the protocol. Sorry for my shaky voice. The cold is terrible. As we say in Venezuela, tricachuo. In the natural coupon, measure the on potential at 600, the off potential at 600, then measure the on and off potential in AC. When you interrupt the coupon, there won't be interruptions. On and off refer to active interruptions in cathodic protection rectifiers. If not interrupting, measure only the on potential. This video covers measuring on-off potentials at 600 and in AC on the natural coupon. Interruptions stem from cathodic protection rectifiers. Without them, only the on potential is measurable. Measure 600 voltage between pipe and coupon. Repeat for structure 2. This guide aids commissioning. Thank you for your time. Despite a cold, I shared my knowledge. Have a great day, afternoon, and night. See you next time. The coupon, when interrupted here, stops interruptions. Discussing on and off relates to active interruptions, cathodic protection rectifiers. Without interrupting, only the on potential is measurable. Measure the 600 voltage between the pipe and coupon. Then, take other readings with the reference cell. On and off potentials in AC and at 600. Repeat on structure number 2, following the same protocol. This list includes necessary. Next, you're going to measure the 600 voltage between the pipe and the coupon. 600. Between the pipe and the coupon, 600, that's the voltage being measured there. And of course, after that come all the other readings, but with the reference cell in the structure, you're going to measure the on potential in AC, the off potential in AC, the on potential at 600, and then the off potential at 600. After that, you'll measure it on structure number 2, following the same protocol. So I included this list of what measurements should be included in the commissioning. Sorry, I want you to have this as a guide, as a reference, so that it helps you when someone says, hey guys, we need you to go do a commissioning. You already know what measurements you need to capture and record in the field. We conclude this video in this way so that it serves as a reference guide. Thank you very much for your time and attention. I had been planning this video for a while, but I didn't expect this terrible cold that has me shaking. So folks, it's a pleasure to have shared my knowledge and experience with you. Again, as always, have a great day, a good afternoon, and a good night. I even had to improvise a support to try to document the information better. We'll see you next time, folks.